Alright, what we got here today is a intervalometer for doing time-lapse photography. So we've got the camera over here. It is a Canon SX60 HS power shot, and I've plugged into the external or remote control port over here. It is a 2.5mm socket like that. I've got a converter to 8th to RCA, and that's how I'm connecting to it. So that just plugs into the camera over here. Right, I've got the camera set for aperture priority, and let's pretend you want to do time-lapse photography. So on the intervalometer, what I've got is you can set the time in 1 second intervals. Okay, here's your stop start button to stop and start the triggering, and I've got a blue LED indicating each pulse, which is 100 milliseconds. So when I push this, it triggers, and you can change that time on the fly. So now it becomes 5-second intervals like that. So you don't have to stop it to change the intervals, because the encoder is being read on interrupts. When it sees a change, it executes a task that changes the time over here. So let's stop it, and I'm going to change the times over here by pushing this button to different increments, because you can set this up for minutes, hours and so on. So 5 seconds, 10 seconds, 30 seconds, 60 seconds, 300 seconds, which is 5 minutes. Then we got 600 seconds, 10 minutes. There we have got 1800, which divided by 60 is 60 minutes. 1800 divided by that, you got 3600 seconds and 1. So if we go for that, there you got 7210 seconds. Now if I wanted to get rid of the 10, I just select 10, and now you got 7200 seconds. So this thing can take photos every couple of hours if you wanted it to. Quite long. You know, there you're looking at many hours, like so. It goes over 100,000 seconds. You know, you can set very long intervals. Right, so let's wind it all the way down. Select 1 second, 5 seconds, and then it goes back to run. And then the moment you press start, it takes the first photo, and now it's taking photos every 5 seconds again. Let's stop it. Now this we've spoken about in previous videos. You've got clock direction and the push button signal coming from here to pins 2, 3 and 4. Pin 6 is the output, which drives the camera, and pin 8 is my push button. So to interface to the camera, what I did is I've used a 2N7000 FET. It's a logic level FET. So I've taken pin 6 into the gate, 0 volts to the source, as well as to the camera 0 volts, and then the shutter goes to the drain. So that's the wiring to the camera. It's very simple. So that's that over here. There's the FET, right? And that's it. You can connect this to, in this case, a compact, but you can use an SLR as well. And there you have it, an intervalometer, a very useful tool, making time-lapse photography, and one can then do whatever you want to with the images, stack it into a video, whatever. So let's have a look at the code. Let me print it out and we'll talk about it. Be back with you in a moment. Alrighty, so here we have the code. So you have y.h and liquidcrystal.h, your libraries for the display. The encoder clock pin 2, 3 and 4. Well, clock direction, push button and so on. Start pin is 8, that's the push button. Trigger pin is 6. Then we got some variables, which is interval and step size. And then that last A, that is the digital input from the I'll get to it later. Last A, we'll see where that was used. It's set to high. Running is false. Intervalometer starts in stop mode. These variables are set to 0. Initialize the display. Set up your I/O. Set up some serial comms for debugging. Attach your interrupts over here for the encoder. So it only looks at clock and direction. It doesn't look at the push button for an interrupt because that's not necessary. Display interval. Update LCD if interval or step size changes. And over here that gets written. If digital read start pin is high, we go to page 2. Then toggle intervalometer. It debounces. It checks for 300 milliseconds. For encoder, button press to change step size. Button press time, wait for release. So that's 1000 milliseconds. So short press changes step size and so on. Debounce 300 milliseconds. If running, trigger the camera at the set interval. So if running milliseconds, the last trigger time interval is less. Camera trigger milliseconds, so there it does the timing. Here it displays the stuff to the LCD. Here's the interrupt service routine. So A and B is your clock and pin. So new A and last A is where it does the counting when you turn the encoder. And then page 3, that's where it finishes the counting of the encoder to set the time. There's your various step sizes and seconds. Now we work in milliseconds, so over here we got millisecond values, okay? Then over here, that's the array which reads which value. It's an array, so the step size selected uses the step size index to tell the code what range you're using. Then serial print that for debugging. If intervalometer is running, it shows running. It's toggling the intervalometer, so it's either stopped or started. It shows the interval, and it shows either run or stop, depending on the state of the running bit. Serial print running, that's for the debugging. And then right at the end, digital write trigger pin high, 100 milliseconds, write the output low, do some debugging, and go back. So that is the code for this intervalometer. Right. So normally with an SLR, if I were to just start it at this stage, set that down to 1 second, the camera would just start taking photos like that, but because this is a compact, it has to be on. But if you're using it for time lapse, the activity would keep it awake. So there we are, taking photos again, just like that. And that's our intervalometer, how to build your own. Ladies and gentlemen, thanks for watching this video, being here today. Hope you're all doing well. Take care. Have an awesome day further, and I'll see you next time for more stuff. Alright, cheers.